Okay, this video is going to talk about solving rational equations and inequalities. I'm just going to mention the equations fairly quickly. I'm going to start with this simple one here, 2 over x equals 0. If I have a fraction that looks like this, just think of it as a fraction. Is there any way that can be equal to 0? No. The only way a fraction could be equal to 0 is if the numerator can be equal to 0. The denominator, I cannot put a single number in there and make this entire thing equal to 0. So the only way that a rational function, something written as a fraction, can be equal to 0 is if the numerator is equal to 0. So when I go to this next one, x times x plus 5 over x minus 7, and this is factored, you may have to factor it. I think about the domain, all real numbers except 7, and then I'm going to look at the numerator. And I'm going to write the numerator down and set it equal to 0. And since it's already factored, I can see fairly quickly that x equals 0 or x plus 5 equals 0, which leads to x equals negative 5. 0 or negative 5 are my solutions to this rational function, because neither one of them is a 7. If one of them had turned out to be 7, then it can't be a solution. This next example, a little more complicated. I can see fairly quickly again my domain's all real numbers except 4. I set the numerator equal to 0. I factor it, x minus 4, x minus 3, set it equal to 0, and that leads to x equals 4 or x equals 3. But x can't be 4 because it's not in my domain. So the only solution I have is x equals 3. So solving equations isn't too bad, but you do have to check your domain, and you probably have to factor. Solving inequalities, and this is maybe new to you as far as solving inequalities in this fashion. You may have to factor this side, but I'm not worrying about that right now. I'm just going to teach you the method. So if I have something that looks like this, x minus 5 times x plus 6 is less than 0, I will get where they are 0, which is 5 or negative 6, and I create a number line. And I put the negative 6 and 5 in order, and then I can pick any numbers I want as long as they're between or beyond that makes sense. Like 0 has to be between negative 6 and 5. I can pick any number I want between them. I just happen to choose 0. I could pick any number I want greater than 5. In this case, I chose 10. Any number I want less than negative 6. Well, negative 10. And the way this works is you're going to take these numbers in black and plug them into these factors. And since I'm multiplying here, it could be division if it was written as a ratio. Doesn't matter. If I multiply or divide, if I have an odd number of negatives, then I know that whole quantity will be negative. That's how this works. So you mentally put negative 10 into this x, and I don't care what the value is, I just care if it's positive or negative. So negative 10 minus 5 is negative. Negative 10 plus 6 is negative. I repeat the same thing with a 0. 0 minus 5 is negative. 0 plus 6 is positive. Do it with the 10. Positive if you have to, but you should get 2 positives. I don't put these numbers in because if I do, I'm going to get 0. I don't care about 0. I care about where this is positive or where it is negative. And this particular one's asking me to solve it for where this is less than 0. So where it's negative. Well, where it's negative is between negative 6 and 5. And when I write that down, right here, the solution would be negative 6 to 5. Notice I'm using parentheses because this is not equals to, so I do not include those endpoints. Okay, so the next one, a little more complicated. I have some division going on. I am going to think about the domain, all real numbers except negative 3. I can't have negative 3 be an answer. So I can't include negative 3 in any of my endpoints, but I can put it with parentheses. The other thing I have to worry about is this is less than or equal to 0. So 2 makes that 0 and negative 1 makes it 0. I'm going to find the 3 numbers that make all 3 of these factors 0, which is negative 3, 2, negative 1, put them in order, then pick numbers in between or beyond them that make sense. All these numbers have to be in order. You can pick any ones you want in black as long as they're in order. And then again, these factors are being multiplied or divided. Well, if you multiply or divide an odd number of negatives, you get a negative. If you add or multiply and divide an even number of negatives, you'll get a positive. That's what this method hinges on. So again, I'm going to take the numbers in black and mentally plug them into each factor and see if I get a positive or a negative. So pause it for a second, see if these make sense while I continue on. Negative, negative, negative gives me a negative. 2 negatives gives me a positive. 1 negative gives me a negative. All positive gives me a positive. I'm wondering where this is less than or equal to 0. Well, it's less than from negative infinity until negative 3. Then the sign changes. And it's also less than between negative 1 and 2. But when I write my solution set, notice how I wrote it. I did not include the negative 3 because in my original function I cannot divide by 0. I did include the negative 1 and the positive 2 in my intervals because that does make it 0 because it was less than or equal to 0. Here's another one. X minus 3 over x times x plus 11. So I have two things in my domain I can't have. I can't write them as endpoints. Luckily, this is not equals to, so everything you write will be a parenthesis. So all real numbers except 0 and negative 11. But when I think about what makes each one of these factors a 0, I am going to put the negative 11 in the 0 and also a 3. Put them in yellow. Pick numbers beyond and between. And mentally plug those black numbers in. And I'm going to look at my negatives. I have an odd number. So it's negative, even number, positive, odd, negative, all positive. Don't fall into the trap that it's always going to be this pattern. And also don't fall into the trap that it's always going to switch signs. This could be just as easily plus plus. We'll have an example with that later. So I want to know where this is greater than 0. Well, from negative 11 to 0 and from 3 to infinity. And notice I did not include, bring it up here, I did not include any brackets because it didn't ask for equal to 0, just greater than. This example does ask for greater than or equal to 0. My domain is all real numbers except negative 2, and the only two values that gives me 0 on top or bottom are 1 and negative 2. So I draw my number line, I put my negative 2, I put my 1, pick appropriate values. Again, I plug these values in, and notice this first factor, x minus 1 squared. Well, when I put anything in there, I don't care what it is. When I square it, I'm going to get a positive. So those three are positive. I put a 0 in to this one. I get in the right spot here. Negative 5 into this one's negative. 0 into that one's positive. 3 into that one's positive. This is the only place it's going to be negative. It's going to be positive or equal to 0 from negative 2 to 1 and 1 to infinity. So when I first write this down, I'm going bracket negative 2 to 1 bracket union bracket 1 to infinity. And I'm including the 1 and the negative 2, and I shouldn't because negative 2 doesn't work, so I'm going to switch that right now. I can't include the negative 2 because it's not in my domain. I include the 1 because it is in my domain. But notice how I rewrite this. Since this is including the 1 union 1 again, I can clean that up and just make it parenthesis negative 2 to infinity. And again, the reason I don't include the negative 2 is because that would give me division by 0. Thank you.